Thank you. Okay, last night, look, we all got a whole bunch of routers out there and we're in trouble because we're kind of exposed. Rob will hopefully sing a little on this subject, but what's the threat model to our BGP speaking routers? And I would contend it's first one's configuration error. If you remember the good old 7007 incident or the 128/8 incidents where, you know, major providers were taken out for days. There's the traffic diversion attacks related to Steve's work, and he'll tell you a little about that. There's distant database attacks or spoofing to try and get my router to do stupid things. There's DDoS to, again, traffic diversion force path. I believe we also need to protect against monkey in the middle and wiretap attackers, and people who wear funny clothes and live near Washington, D.C. are pretty strong about that. And I believe that I don't want an interim solution that I'm going to have to rebuild my network all over again with a second solution later. But I do want to strongly make the point that the danger we're talking about to your routers and to my routers is not theoretical. It's stuff that is happening and has happened. As long as 2 years ago, I know of a backbone that I worked on where it was owned for at least 6 hours. The only reason we detected it was somebody, one of the miscreants, touched a configuration, and the sweeper that watches configurations every hour caught it. So this is not a theoretical sign. This is real. Your routers and my routers and the working internet are seriously threatened. Okay, this picture was a road just a week and a half before this picture was taken. You don't want this to be your network. Maybe you do. If you remember in February 2000, at the last hotel where the water was so soft it took you half an hour to get the soap off you in the shower, like this one, Steve first described DDoS attacks. As he was speaking, the first major attacks on big sites occurred. Let's hope that today we don't re-experience that. There are essentially two proposals, each poorly documented, wandering around the ITF space for solving this problem. One of them is soBGP by Steve Kent and crew at BBN, which Steve Bellevin will characterize for us. The other is SO, Signed Origin BGP, which Alvaro will characterize for us, that's floating around the valley. First, we're going to hear a little from Dave and Andrew on operators' views of this. And then I'm going to try to sum up with where I think my personal prejudice is, where we can go forward in a compromise. Unfortunately, neither of the two things they're all relying on expired -00 drafts. There is no current solid work on these protocols, and we'll get you some detail later. Let me toss it on to Steve. You want to plug your laptop in, Steve? Here, I'll get rid of this one.
Okay, I don't have any pretty pictures or any nice pictures like that, but I can say that if I had a network, I'd want it to be on Hawaii. Okay, this is a work in progress between Andrew, I, and everyone else in this room, so it's supposed to be interactive. I've gotten a lot of information from all of you as we've been building these slides, so stand up and talk anytime you want, that includes Andrew. So in looking at this, Andrew and I were tasked with kind of coming up with what our operator hat perspective looked like. So here's the agenda we came up with. First, oh, by the way, how much time do we have, Randy? Do you know? All right. Okay. We wanted to try to characterize the problems we were trying to solve. Then ask the question, why aren't we deploying one of these two or other solutions? What are the complexity issues? And what's the 10,000-mile view that we're looking for anyway? And maybe if we have some time for discussion, we'll do that. And these slides, if anybody should happen to want them, are there. If somebody wants the magic point source, I can give you that too. So here's the view of the problems we're trying to solve. As Randy pointed out, there's a lot of threat model work going on, including trying to characterize configuration mistakes, prefix hijacking, compromised backbone routers, DDoS availability, some new attacks like the one that Steve and his co-author just published about using link cutting techniques. And then, of course, there's the whole set that are new and things that we haven't seen or detected yet. So a lot going on here. And I showed these slides to Rob Thomas just hoping, to get some feedback. And here's the first thing he gave me. He basically said, this is real life and something that we really need to be looking at right now with some, as Randy said, with some urgency. So in case you were wondering, hijacking and ownage is a big problem for us right now. So if we look at this and we go, well, okay, we have these huge problems, why aren't we deploying some kind of secure BGP right now? Well, as Randy pointed out, there are two kinds of works in progress on this, secure BGP and secure origin BGP. And the question that came to mind is, well, why aren't we deploying either of these? Well, the first one is, doesn't appear that there's any community consensus on what the right solution to this is right now. These are proposals, and as Randy said, they're works in progress in various states of documentation. Danny. Danny.
Can you hear me now?
Yeah, I can hear you.
Okay, so I'd actually be happy to see...
Who are you, and can you speak up a little bit?
Danny McPherson. I'd be happy to see interprovider route filters, much less, I don't know, all this stuff. So.
Okay, we'll get to that. Thank you. Okay, so as Danny points out, there's no community consensus on this. There's a complexity issue here, and we'll get to that in a second. And there's also sort of a paradox trade-off, as there always is with complexity, but in the security area, it's sort of acute. And this is the quote I like from Steve when I was trying to write about complexity and what it meant for security and whatever RFC 3439 or whatever that thing was. He said this, which is true. So we're kind of have a paradox here, or at least a trade-off that we have to be cognizant of that we're making. So what about the complexity aspects of this? Well, both SBGP and soBGP seek to protect different parts of the routing system via cryptographic means, but there are some common things that we can talk about. They both want to protect allocation of IP addresses and AS numbers, of course, and in some cases protect the granting authority for the chunks of address space that are out there, and for the BGP messages and peerings. This is one of the places where soBGP, and I think Alvaro will probably talk about this, but this is one of the places where they diverge, because SBGP seeks to really protect the entire end-to-end system, where the soBGP authors take this as a different part of the same overall problem. So in general, you might want to authenticate every step in the life cycle of an IP allocation of an IP address and how it's used. From the IANA, from one ISP to another, to the customer, to the AS number allocations, to permitting an AS to originate routes for some address space, and in general, all BGP traffic, including AS paths, which would protect against some of the things that Randy was mentioning, next hops, all of it. So I was talking to Rob about this again, and here's what he said. I just find these kind of interesting because he injected some pragmatism into the whole thing, and basically he was saying that so many routers don't have ACLs on their VTYs, much less all of this other stuff. So if it's hard to do simple, how can we do complex? So that's something to keep in mind. So all of that stuff is out there floating around with the designers of both of these protocols and with the operators. But what's our 10,000-mile view? What do we want out of all of this? Well, I think we can agree that almost every BGP speaker should be able to verify that the address space has been properly allocated, that the AS origin AS is valid, that the entire AS path being valid is one of the ones that we'd like, but we're not sure. That's a point of contention. Other attributes, and in this case I was thinking about, because I've had BGP signaling for VPN on my mind for a while, and so I was wondering, well, if you're going to do this on IPv4 NLRI, are you going to do it on IPv4 VPN LRI or L2 VPN NLRI? And in addition to that, is that too small? I don't know. In addition to that, are there security or even other implications of continuing to throw almost everything into BGP? What does it all mean? So the thing to note is that there are cryptographic signatures that will need to be checked and verified at various steps at different places for the different approaches. But at the 10,000 mile, we'd probably like to have a system that would do all these things for us. But all of this comes at a price, and of course that price is operational complexity and additional infrastructure. So what can or should we do? So here's one of Andrew's ideas. How about pre-collecting all of the information into a local database and running an authentication checker there? Only send the router pre-compiled chunks of data instead of everything. So these are incremental approaches that we've been thinking about. But the router still needs additional processing and memory to be able to handle all this. So that's something to think about into the future. And it's still unclear how big this information would need to be, or how much of that information a router would need to carry around. And one of the things that, of course, we're always concerned about is introducing new dependencies into the routing system that would make it either converge or recover more slowly. And so that's something to think about. So continuing on what we might do, a point of all of that discussion is that there's a non-trivial amount of infrastructure that we need to support to do this. Databases, certificate authorities, all of that stuff. What's the effect on BGP convergence? We don't know. Here's the one that's kind of near and dear to my heart. Who pays for all this? Because as we know, CapEx and OpEx is kind of the frontier for the carriers these days. And there are also free market issues, like what's to stop a user who from moving to lower cost ISPs who don't provide this service? And in fact, would this generate a new kind of no SLA service? And if it did, what would that mean for the system in general, as a whole? The routing system of the global internet. So how about administrative delays? This is something that came up earlier. That is this going to inject time into getting a prefix announced, which people seem to be unhappy about as it is. Well, for soBGP, signatures and certificates have to be generated in the same way as with SBGP, but the propagation of the information is different. And instead of relying on out-of-band databases and some form of synchronization, the certificates are advertised in a new message, the security message. So this thing should have propagation delays and timings that look like update propagation. So in theory, SBGP won't add any administrative delay to getting your prefix announced. In theory. How about SBGP? By the way, do people see that as an issue? Time from when you get an allocation to when it can be announced? Avi, can you go to the microphone and tell who you are and all of that good stuff? Yes, you can go to the microphone and tell who you are and all of that good stuff, or yes to some other question.
Yes, I do think it's important. Also, given that SBGP or soBGP or other competing proposals, which may or may not exist yet, will not be completely deployed across the internet initially, One of the defenses when someone is actually trying to attack your space or hijack it is to, at least even for your own space, announce it more specifically. And being able to do at least that, I think, is important. And if there are places where, when you have a split model where some people are not running any advanced protocol and some people are, I think you need to be able to react pretty quickly to that. Also, I work with some providers where we've had customers who had legitimate need to announce new address space pretty quickly.
Well taken. Well, okay, so let's look at what we think might happen with SBGP. Of course, this is all hypothetical, right? Because we don't have it. But so the question is, will it take longer to get a new address routed if we have SBGP out there? And the answer to that is maybe, and why is because of the fact that all the signatures involved have to be generated, signed, published to a local database, and pushed around in various ways that are not necessarily congruent with the update topology. And so the question we have on this one is, are we willing to make that trade-off as a community or as individual providers? It's a question that needs to be answered. So finally on all of this, sort of finally, if you think about the additional processor and memory storage needed on a router, at least for SBGP, it's going to cost somebody something. And again, back to who pays for this? Are we going to raise the price of the service? How's this going to work? And I think Randy has some thoughts on that. We talked about that earlier. There's an alternative position on this that maybe goes to what Danny was saying earlier, which is how much of this problem can be solved by currently deployed techniques, like BTSH, ingress filtering, unicast. I think I have pointers to this for those who don't know what they are. Unicast RPF, and maybe cleaning up the registry systems and things like that. How much of the window could we close? It's a question that needs to be answered. And if we could, would it be enough? How would we define enough, and for how long would it be enough? So the question is this an incremental? Could we do something incremental in the sense of incremental like Randy was describing, or would this just be the Band-Aid and then we'd throw this away when we got something better? There's a lot of opinions on this one out there. I'd be interested in what people have to say about that. So trying to get some final thoughts through here. What are the cost-benefit trade-offs we're looking at? Those are really difficult, and so far I haven't seen any real quantification of that. If anybody has thoughts or ideas on that, please step up and tell us about it. Is there an incremental deployment model? We think there might be with both of these. In the case of SBGP, we might be able to start with just signing the origins, and then over time build up forward signed AS paths or something like that. And it's important to note that soBGP has a different model where it doesn't sign updates, but instead it has the certificates in the security message. Oh yeah, and of course, if you ever wanted to write a draft about this and have it go through the iStar, you'd have to deal with this last thing, which I'm not sure how much trouble that causes. So finally, the reading on this, as Randy said, these documents are all kind of in various state of decay, and this is where they are. If you want to look at them, I highly advise reading both of them. So the question becomes, what are the next steps for the operator community on all of this? Just sit here, try to deploy one of these, try to find a new model, try to make them all come together, where to go? That's the question that we really need to answer. Okay. Mr. Rob, breaking news. Uh-oh.
Hi, everybody. Rob Thomas. Those of you who know me know the hardest thing I will ever do is stand still at a microphone. But I will try. So, we're talking about... Yes, sir.
See, we have the technology. We can rebuild him.
Jerry Springer, begin. So, we're talking about BGP threats, and one of the problems we have is that there's still people out there, the unbelievers, who don't think this is a real threat. So, I've got breaking news for all of you. How many of you have routers that speak BGP? What a crowd, what a crowd. I'm going to teach you how to own any BGP speaking router. Ready to take notes? Because it's going to stay in the room, right? Okay, here goes. Are you ready for the command? It's one command. Bang. B. G. P. S. Enter. That's it. This is how the miscreants get your routers. People will compromise routers that speak BGP. They will target them, by the way, and then they will make them available in the underground economy. And to get one of those, it is as simple as typing bang BGPS in certain channels, and out comes a router IP. What do you suppose the password is? Cisco. C1SC0, that one always stops them. The point here is that routers are being owned on a massive scale, and routers that speak BGP have an even higher value. By the way, for those of you who are going to go shopping for your own routers after this, some of those vending bots require a valid credit card. How many of you think the miscreants use their own? The point I'm trying to drive home is, if you think this is not a threat, I'd like to know your AS number. This is a very real threat. It's very real in the underground. They're taking advantage of it today and have been for quite a long time. Quick thought. Why would anybody want a BGP speaking router? Well, Rob wants them because they're cool. But they want them for a variety of reasons. Spammers pay big money, and when I say money, I mean real money. Not credit cards, not shells, not other routers, not proxies. Because they will use BGP speaking routers to announce allocated yet unadvertised space to figure out if anybody will squawk. How many of you think you would notice if somebody announced a more specific prefix under your prefixes? Oh, Abby, put your hand down. We knew that. This is the thing they'll do. Think they're not subscribed to NANOG? So once they figure out that space doesn't cause any pain, any squawking, they will then turn around and use it to generate spam. So those of you who've been Joe Job, not just of your domain, but perhaps of your prefix, now you know how it happens. By the way, there are people who call themselves IP brokers who will do the same thing, pay some miscreant to announce a net block to see anybody squawks, then they'll turn around and sell, quote unquote, that net block to very naive providers. Dude, I really need a /16. I can help you. The low, low price of.
I've got some swamp space to sell you.
So, the very quick point, and I'm never quick, that I'm trying to make is that this is a very real threat. But it doesn't take much to raise the bar. Those of you who have Telnet open to the whole world, those of you who use Cisco or Cayman or whatever as a password, this is your wake-up call. It came too late. Your routers are probably already owned. So take the time to raise the bar, do the simple things, listen to what these fine folks are saying, and get on board. Because we're already behind. This isn't a case of let's beat them. We've been beaten. Now we need to recover. That's it.
Rob,
Yes, sir.
so we raised the bar by cleaning up the stupid stuff, and turn off Telnet on your sticking routers, et cetera, et cetera. Get some access lists in there. How likely is it that the bad boys and girls are just going to follow the raised bar?
Well, the underground is an amazingly adaptive place. So as we raise the bar, so will they. The interesting thing, though, is that the underground is also an incredibly lazy place, by and large. So let's face it, folks, we've not challenged them. We've not made it difficult for them to do what they do. And by the way, now they're making real money doing what they do. They've got motive, right? They have customers to satisfy just like all of us. So they will raise the bar, but we need to buy that time. We need to start excluding the simplest of miscreants. We need to make sure that you can't just type bang BGPS or bang Cisco or bang Cayman or bang anything else and get 20 of the things at one crack. To give you a feel for how bad it is, one bot I recovered, and this is over a year and a half ago, included 3,400 compromised routers to be used by the bot as a proxy. all 3,400 worked. I didn't test it. I'm not like that.
How many ASs?
It was about 17. So, you know, if that was over a year and a half ago, what do you think it's like now? Much better, of course, Rob. So, again, keep in mind, this is a very real threat. Don't talk theoretical anymore. Those days are gone. And that ends my gloom and doom.
I'll try to be quick. 3 points. The simple thing to watch for that I've seen a lot is people who set up their own TAC servers. How many people run TAC? TACAX? Anyone? No? I guess I'm alone. Have, you know, the router people set them up because you wouldn't trust those IT people to touch a Unix machine, and then haven't looked at the machines for 2 or 3 years. So I would encourage people to consider regularly auditing those machines. Second point, we actually monitor for more specifics, change in origin AS, although we don't monitor change in, you know, the middle of the AS path, about 20 different organizations, including all the Akamai deployments. And in the last year that we've been doing it, we've been monitoring about 3,500 prefixes. We've only seen one attack on a prefix that couldn't be attributed to just a misconfig. That doesn't mean that it can't be done, but I think that's part of the problem, is that it hasn't been done enough. It absolutely is happening, but not enough. Third comment, I think that you asked, Dave, what the provider community can do. I think be proactive is a good thing. It's easy for me to stand there and be critical and say, SBGP is silly because no one's going to deploy offboard route processors, and no one's done simulation assuming paranoid levels of CPU load or BGP load, and the people who wrote it have never seen, you know, routers operate and don't understand that 60% average load doesn't mean that you aren't often running at 100%. But trying to think about how to be constructive, and maybe it's educating the people who are working on the designs, or maybe, you know, in terms what you could realistically deploy, maybe that's what the provider community can do. So far I've been a little bit stumped myself, but that's why we have so many smart people sitting around. So.
I think the point that Rob's got, we shouldn't belabor too much. We needed Rob to make the point. This is a very real and very current problem. And it's not going to get better, it's going to get worse. One message I have is, should we be having a panel next time and a discussion of the basic stuff you should be doing to secure your routers today? Or tutorial? I think that's a point, but I think we should focus the rest of the panel on here to long-term protocol strategies for trying to get strong crypto protection for what we're actually hearing in BGP. And you'll excuse me for being an idiot and just concentrating on that pretty much for the rest of the time. Steve? Want the one?
I can stand at least more still than Rob. So we're talking about SBGP. I'm channeling Steve Kent here. Oops, I think I've got the wrong slides up. Yeah, I've got the wrong slides up. Excuse me for a second. Randy and Dave referred to this new attack of mine. You can find it on my webpage called the link cutting attack. Basically, we demonstrated that it's computationally feasible, assuming you own a few links or routers, to calculate what other links you want to take out to force the traffic to go past the nodes or links you control. It's kind of an optimized backhoe attack. We demonstrated this with real data from real internet topologies. You can find that on my webpage. The nasty thing about that attack is that's an attack that succeeds even after we have SBGP. So we can, but maybe more interested in the people who wear funny clothing around Washington when they want to go take out various unfriendly parties' links. There are problems with trying to do secure BGP. The problems come from a lot of different spots. One of the simplest is configuration errors. But of course, if I'm off the air, I don't really care too much why I'm off the air. whether it's a configuration error or whether it's malice. I'm off the air. Another is fraudulent origin. Someone who's got deliberately announcing a route, originating a route that they have no right to do. This is what we're seeing today, what Rob was talking about. Fraudulent modification. Maybe someone in the middle of the net isn't modifying an AS path or announcing something that looks like a legitimate AS path, but it goes through some ASs that they control. And this is happening by compromised routers and by compromised administrative and configuration systems. And the bad guys can get in either place. It may be happening, especially with the more advanced threat models, by wiretapping and active packet injection. We don't know if that's happening as much. It could. That, by the way, is the threat model, things like the TCP, MD5 options designed to protect against. The basic model of soBGP, and I said I'm channeling Steve Kent here, is routing origin is digitally signed. When you get an address block, when you start announcing it, you have a certificate saying you have the right to this address block, and you sign the route advertisement at the very beginning. The more interesting thing is that the updates are digitally signed. Each update you send out is digitally signed. There's an address-based PKI used to generate these certificates. You get your addresses from the RIR, or from your upstream, or from your provider. When you get an address block, if you're a BGP speaker, they give you a certificate with it. There is no new trusted party in this. You're getting your certificate from the same party who's giving you your addresses, so there are no new trust paths. There is new software, there's a bit new procedure, but once this thing is in place, I don't think there's going to be any delay once we're in steady state on using this thing, because when you get the address block, you'll get the certificate along with it. The most important thing that happens is that the signing party signs a message saying, this is who the next hop on this AS path is. And this chain of signatures gets carried along with the BGP update messages throughout the net as an optional transitive attribute. Yes, this does expand the size of BGP messages. The steady state overhead is actually not bad. It's the startup overhead that can be expensive in terms of bandwidth. The certificates mostly live near each BGP speaker. You can send them in the BGP updates. Generally, you won't want to do that. But this is one thing you would want to do at startup when you get to start announcing a new prefix for a couple of days until the certificate has made it to the various repositories. You start sending it out with the updates. And this isn't a problem. Certificates are self-verifying. You don't need to trust the path by which you get a certificate. You could simply verify it. There are a lot of optimizations to the basic scheme. You can do lazy validation of routes. You can cache signed so-called route attestations or address attestations. If you've seen it before, you keep it. When things are flapping because topology is changing, you don't completely discard all knowledge of a particular path. You mark it as not usable at the moment, but you keep it in your cache. When you see something new that comes via that same path, you look to see if you have a previously validated signed statement of that path. If so, you don't have to go through the expense of calculating the digital signature verification again. Cost. Steady state overhead is estimated about 1.4 kilobits per second. The startup transient is worse because it's suddenly sending out a lot more messages. It's not free, but it also doesn't look to be a killer. It does consume a fair amount of CPU. It would be a good idea to have crypto accelerators on board. It will consume a fair amount of extra RAM on the BGP speakers. Yes, this is going to be some expense. My own personal feeling, and I'm perfectly willing to be proved wrong, is that the cost of a crypto accelerator chip and a bit more RAM, this doesn't have to be the really fast RAM, by the way, is going to be fairly small compared to the cost of a GSR. It is not going to be a very big percentage increase in the cost. It could probably be folded into the regular update cycle because we're not rolling this thing out tomorrow. It's going to take years to deploy this thing, get people to start doing the signing, and My own personal guess is that the ordinary upgrade rate, assuming the economy ever starts again, will suffice to get this in place with a fairly small percentage cost. The real cost is the operational cost of maintaining this PKI, and for that matter of cleaning up the address allocation records and issuing the initial certificates to start with. But any form of secure routing is going to have to go through that. We're going to have to clean up the databases and issue some form of public key credentials to people who own address blocks. The PKI is complex. You know, the latest paper by Steve Kent and company is something only a PKIT geek could love, but it's based on existing trust relationships and existing business relationships. That's a very important point, because this also means there's an existing authentication relationship. It doesn't do a great job of handling withdrawals. I can't sign a withdrawal notice for a path when the link over which I would announce it is down, and that's why I have to go withdraw the route. This is kind of a fundamental limitation here. And I said, you do need router upgrades to do this in its full glory. TCP MD5 protects single hops against active intrusions on the wire. The BGP TTL security hack protects against people who are off-link. These are good against certain kinds of attacks. They don't do any good against false origins or a subverted router in the middle of the network. And, you know, that happens. soBGP does a good job guarding against origination fraud. I don't think it would do as well against guarding, well, monkey business in the middle of the network. And none of this protects an evil router that's on the legitimate path. Running code exists for soBGP based on Gate D. This webpage, Steve Kent's got papers, talks, and code. Pick it up from there. I said, I'm channeling Steve Kent, so I will now try to go find a nice Cabernet or Burgundy. Questions?
I just had a quick question. Could you describe what would be the effect if, say, just the largest 5 to 7 networks in the United States decided to put in place soBGP because they already have repositories, they have the technical staff and expertise? What would be the effect on the overall infrastructure?
The most important thing is that people who wanted to trust this stuff would have to know authoritatively that certain address prefixes were supposed to be signed. After all, you can be a large company who's doing business with a small ISP for whatever reason, and maybe they're not doing it, so you suddenly start seeing a signed path for your large prefix coming from a big ISP, and an unsigned path for a more specific prefix coming from a small ISP. And is that valid, or is that someone trying to hijack one of your prefixes? And you have to have some authoritative way of knowing that all prefixes in a large block are supposed to be signed. It would, as with many other things, it would tend to, if you did it that way, tend to concentrate. People who cared about security would go more for the big providers. I work for a big provider, so I suppose I'd have to consider that good, but it would be in effect. But realistically, most prefixes are coming from, and most addresses are coming from the big providers. We could go a long way to securing a lot of traffic if we were the big providers doing this. Of course, big providers are not immune to having routers compromised either. That's happened too. It's not just something that happens to the little guys. But yeah, this would help, even if it's just the big providers.
One part of the answer to that is maybe Steve's talk didn't make it quite as clear. One of the salient features of soBGP is that when Andrew makes an announcement to Dave, who makes an announcement to me of a prefix, Andrew signs that announcement saying, I am sending this prefix to Dave. So that, and that prevents a spoof. That prevents all sorts of other spoofs. It prevents somebody else from saying, I'm Andrew and I sent it, here it is. Okay, Dave signs further when he sends it to me, signs and says, I'm taking this prefix, and Andrew's signature's on it, and I'm sending it to Randy. Okay, so we have the path. And to answer your question, I'm not sure I really care a lot about it, but at least when, Vario hands it to Sprint, hands it to me, I know that part of the path was really intended and not spoofed, even if the prefix may not be one whose origin is registered. I would suggest that the origin registration is something that should be pushed, but you've at least got some knowledge that the last steps on the path are certified.
Sort of follow-up to that would be, for those paths that are not authenticated, authorized, blessed, that they were indeed acceptable into the BGP mesh, is there a point in the future where those who are not signed would be dropped and just assumed to be non-authoritative announcements, in which case there might be a fragmentation and everyone has to go through the process of adopting the SBGP, hence the flag tag?
That's far enough in the future that I don't think anyone has thought about that question yet. My guess is that it will never be enforced that you have to have only signed routes, because we're not there yet. I could easily see some people, some parties refusing to talk to you if it wasn't over a trusted path. But the real important thing is to know authoritatively that a path is supposed to be trusted.
Let's face it, by the way, you're in an internet today where a large number of hosts refuse to, or sit behind routers that refuse to speak to a large number of other chunks of address space. I'm specifically speaking of the issue of the American military trying to pretend they're on half the internet.
Steve Wilcox. Very similar point, actually. If you haven't got 100% rollout on this, surely small ISP over in Asia somewhere who's announcing through bigger ISPs gets to you eventually. If they announce you are more specific, it's not signed, but you've accepted it because you've had to, because it's come through it, you're still going to have exactly the same problem, and it's more likely that someone like that is going to cause the problem anyway. So unless you've got 100% rollout on this, it's never going to work. And how do you get 100% rollout? You've seen it with other systems. It's just so difficult to do.
If you've got a small ISP that's home to two big ISPs, the two big ISPs can be signing it and just not giving a certificate to the small ISP, and it's covered by the big ISP's signature. That should work.
This is a business social issue, and we have the same. It's a friend of who listens to what prefix lengths, etc. And I believe we will be in a point where we're not going to listen to a large part of the net is not going to listen to routes that are not well authenticated. A large number of mail servers are not going to accept email from clients who do not authenticate that email in reasonable ways to reduce spam, etc. The internet is going to tighten up.
Hi, my name's Tony Lee. We've been having this discussion for the better part of 5 years. We have a practical problem on our hands. I've heard somebody stand up and say that prefix hijacking is happening now, and kind of tend to believe it. Why don't we just fix that? This is a non-trivial problem for us to fix, but this is the first step in getting it right. And we have a problem here. The first thing that we have to do is to have some secure mechanism for delegating IP address blocks. And I don't care if it's on CDs that get mailed out monthly, whatever mechanism it is, that's the absolute first thing that needs to happen.
Any solution, SBGP, soBGP, something no one else has thought of BGP, is going to require really good, reliable data on who owns what address blocks. And that's SBGP came out of National Research Council Study Committee that Steve Kent and I were on. Steve Crocker was the original chair, and Steve McGeady was also on the committee, so we got, this slide seemed appropriate, this cartoon seemed appropriate, but Steve went off and worked on SBGP, but yes, there is a problem. It is going to get worse. We need to start solving it. About 2 years ago. Jeff Schiller, I'll save you the trouble of introducing yourself.
Wow. Well, that sort of throws me for a loop. Actually, these proposals do make an interesting change. At the beginning of your talk, Steve, you said it doesn't change any of the business relationships, and I actually beg to differ, because it changes the nature of the relationship with the routing registries and end users. Right now, I hardly ever deal with my routing registry. I don't have to. I got my address space. As long as I don't need to change anything, I'm fine. Certificates, on the other hand, have this thing called an expiration date. And you have to make sure you get a new one before the old one expires. And that process has to work well. And in any customer service situation I've been in, if you're dealing with a monopoly, it's not fun. So I'm not saying we have to throw away SBGP or soBGP, but I think we need to be careful about how the business and relationships work and the trust relationships. For example, not to go into all the details, but I'd be very happy if those digital certificates were actually created by my ISP, because I have a business relationship with my ISP that it's in my ISP's interest to maintain. In the case of the routing registries, I don't care. I mean, they don't have to. I have nobody else to go to. And I can give you numerous examples where, well, just, for example, this is not a routing registry, but it's a DNS registry. My, contact data for MIT.edu was fouled and unchangeable for 5 years because I couldn't get anybody to pay attention to fix a broken system that they had, and it only got fixed when they became competition for registering things. And so I can easily predict cases where you can't seem to get that certificate renewed because there's some bureaucratic foul up over here, and meantime a clock is ticking, tick, 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 tick.
I think slamming VeriSign is kind of the operator's equivalent to Godwin's invocation. So next, let's cut it off at Peter, because we do want to finish the panel.
Okay, so I'm Peter Lofberg. I'm not sure we are getting things in the right order. This seems to be something that needs to be fixed, but we have another similar thing in the internet that I would like to see working first. That's called secure DNS, because that has all the same kind of ingredients, has all the same kind of problems, and if they are further down the path, they even have a protocol in the IETF, and damn it, why can't you make that work to start with?
I'd love to. I strongly agree. That same NRC committee I mentioned said there were two major threats to the internet. The other one was DNS.
Hi, I'm Alvaro Ratana. I work for Cisco. I do routing. The link down there, if you can copy it real quick, that's where the slides are at right now. They won't be there much longer, but if you want to follow with this, you can get them. Okay. So I'm going to talk about soBGP. We have many of the same objectives, of course, and are coming from many of the same threat models as everyone else. What is different is the way we are proposing to do things, pretty much. So we all know the internet is very important. It ties everything together. We all know it's vulnerable to many things. And the reason why one of the reasons we're here to talk about both SBGP and soBGP is because this solution requires end-to-end agreement versus many parts of the overall security of the internet that are point solutions that can be deployed on a router per router or peer per peer or session per session basis. Things like inbound filters, maximum routes, any other router specific implementation enhancements, also including things that are not part of the protocol itself, like securing a compromised router, which does affect the protocol and does affect the system, but is, at least in my opinion, of course, outside the realm of the protocol and what the protocol should protect. The other part of it is the transport connection. We, in our work, don't mention or don't make reference to using IPsec or MD5 or anything else, because what we believe is that is one of those other mechanisms that can be used to protect part of the whole system. We are not in any moment against using IPsec or anything else. In fact, use whatever you want. soBGP and the part that I'm talking about here, and the part about verifying the origin, authenticating the path, etc., that SBGP also covers, works over IPsec or non-IPsec. So soBGP is trying to solve the problem of validating that an autonomous system is in fact authorized to originate a prefix. And by doing that, we also can verify that the path is a valid path to the origin of the advertisement. So we started down this road by putting ourselves some design requirements. And these are some of them. One of them is we want to take advantage of the existing internet architecture, the trust relationships that already exist, the way addresses are, for example, assigned and delegated from ISPs to customers down, etc. We want to, of course, impact as the least we can the current protocol and the current system. So the objective has been minimum changes to the protocol as much as we can, and try to optimize memory and processing requirements. We don't want to rely on any central authority to do anything. So as I talk further, you'll see that what we're proposing is a distributed system that has implicit trust in it. We don't want to rely, or we should never rely, on routing to secure routing. What I mean there is if I have to go someplace using my BGP routes to verify that my BGP routes are secure, it kind of creates a circle of trying to get someplace without verification that the route to get there is actually valid. We wanted, of course, and I'm sure everyone wants it to be incrementally deployed. Part of importance here is that if it is incrementally or partially deployed, you have to provide some type of security to the parts of the system that have implemented the security mechanism. Deployment flexibility, on or off box, for example, cryptography processing, which is another important thing. And the last part here, flexibility, so that each operator or each autonomous system can configure their desired security level and overhead and conversion speed, for example. This last point is important as well because today we all know that there are 25,000 different BGP knobs, and everyone has the ability to implement them independent of everyone else. So what soBGP does, and over the next couple of slides, I'm going to just summarize what we do. We verify that the originator is in fact authorized to originate a path or a route. We can verify that the S path represents a valid path to that origin. What we do is we have one extension to BGP, which is a new security message. This is not an attribute, it's a message. So what this means is it's carried separate from the updates. And it can result, as I'll say a couple times later again, it can result in you having a BGP session that only carries updates, or a session that only carries security information, or a session that carries both. The point here is that we want to carry the certificate and security information inside the protocol itself, so that, again, we don't have to rely on external sources to get that. It has fixed additional scalability requirements. The certificates and security information is generated once per entity. What we call an entity is an autonomous system, and per block allocated or assigned. This means the system doesn't grow in memory requirements as the number of prefixes increases. Takes advantage, as I mentioned before, trust relationship, loose AS associations, etc. So we're proposing a web of trust to validate the signatures and the certificates. So if I want to trust my ISP, I can trust my ISP. If I want to trust IANA or some registry, I can trust IANA or some registry, whatever I want to do. There are 3 certificates that we have defined so far. The entity certificate, which is used to establish the identity. So this is the information that is carried around to say, yes, I am in fact AS number 109, etc. The authorization certificate, which is the one that delegates, or the one that shows that a specific autonomous system is in fact authorized to advertise a specific prefix. Usually this is going to be signed by someone who has authority over that prefix. Again, ISP, registry, whoever you want, whoever you trust. And then there's a policy certificate. We're going to use this certificate for a couple of things. One is to carry what we call a topology map that we're going to use later so that we can verify the path. And the other one is if the origin wants to apply specific policies to their block or specific prefix, they can announce those policies in here, and of course sign the policies and make them secure. Some policies may be things like, I have a /16, and the biggest block that I'm going to advertise is 24s. So no one, even if they actually spoof the origin, could advertise anything bigger than a /24, for example. And again, we're proposing a web of trust as a method to do this. And last but not least, of course, built-in flexibility. As I mentioned, you can propagate updates or certificates together, or decouple the propagation of them, so that you don't overload routers with certificate information. You can have on or off box cryptography operations, incremental deployable, configuration, etc. So I mentioned we have a separate message. We call it the BGP security message. And this is how we're going to transport the certificates. All the security message is a set of TLVs. Each TLV represents a certificate that you carry and you exchange with your peers. Via a simple TLV message, you can add other certificates if you want later. It also means you can only receive the certificates that you need. Every time you exchange this information with your peers, you don't have to get everything again. You can only get some of them. And the last point down there, which I know I've said several times, but it's important, is you can have certificate only, update only, or both sessions. Of course, everything's negotiated startup with capability, as everything else is. The important part about the security message is there is no information inside an update. So there is no additional processing need or storage for anyone receiving an update, even though it is secured by soBGP, because the information is carried separately. So this is my one slide that explains the whole system. So I'm going to go through it. So what we start with is a set of known keys. Your ISP, for example, known keys that you have, the match ASs. As entity certificates are received, we can validate from the known keys as the signature is actually valid, and in there, you of course have identity of other ASs and their keys as well. So your table of keys, etc. grows. Policy certificates carry 2 things. They carry topology information, and what this is a list of other ASs that you're connected to. This is no more, and sometimes actually less, information than what it is propagated today in the AS path of a route. There is no specific information about peering, types, or addresses of peers, or nothing like that, just ASs. So this goes into what we call a topology database, which later turns to be a topology graph, not a tree, a graph. The idea here is we can then validate, doing a simple 2-way connectivity check, and say, yes, AS1 says connected to 2, and 2 says connected to 1. Yeah, that has to exist. This also lets people implicitly withdraw routes by announcing that the connection doesn't exist. So if my connection to my ISP went down, and my ISP turns out to be a bad guy, and they keep advertising my announcement, my update, I can always send a new topology map through my alternate multi-home ISP, announcing that that link is not valid anymore. The other part of the policy goes into what we call a policy database. The authorization certificate, of course, has signatures again that say this AS is authorized to advertise /8 or whatever. There's a very tight bond between the authorization database and the policy database, so that policies get applied to addresses that are announced, that are authorized to be announced, and vice versa. So this is pretty much the pre-work, or the work that has to be done cryptographically, resolving all the keys, looking up all the information, etc. When the actual update comes in, there is no crypto processing of the updates. The assumption is, of course, the topology graph and the authorization database may be pre-built. So all we need to do is two things. We check the origin and the prefix against the authorization database. Got an update from AS1 for 10/8, check it there, is he authorized or not, yes or no, whatever. And then we can check the AS path against the topology graph and figure out if that path is in fact a valid path to the destination. If you actually downloaded the slides, I just skip 10 slides of what you have down there. I just want to show a quick example of some deployment scenario. This is a simple network, and what I'm trying to illustrate is the 7007 problem. So the problem was 7007 deaggregated everything back into the internet. So the way that happened was they just deaggregated and announced stuff as originated from them. The way soBGP prevents this is very simple. The origin of the routes is now 7007. Authorization certificates say, nope, they are not the ones authorized to do this, so we can just get rid of all the routes. Another possibility, which wasn't what happened but could have happened, is let's say that 7007 in fact announced an AS path of the origin and then themselves, so that when we look at the databases we find out, oh yeah, the origin is authorized to announce this. But when we verify the path is not valid because there is no link between the origin and 7007. So that gets blocked at the first hop ISP. Another thing that could have happened that we can also protect against is the fact, let's say that 7007 was actually multi-homed and that they just kept the original AS path and propagated the information back to the multi-home ISP, which I call ISPM. So the AS path is the same as the original one that they received, which means we can verify the path. We can also verify the origin. So here's where some of the functionality of the policy certificate comes in. There are a couple of things we can do here. One of them is there is a bit indication in the policy certificate that indicates this AS is a non-transit AS. ISPs can use it for the customers that they want to. The other option is if you don't include that connection in your topology information, that prevents the autonomous system from transiting your routes. So if I was an ISP, I would probably not want many of my routes to go through my customers, cable customers, for example, or anything else. The other way that this can be prevented is, knowing this was a deaggregation problem, is by the origin advertising a policy that says, I'm only advertising /16s. If you get anything bigger than that, even if it's from me, ignore it, etc. So what do we need to run soBGP? Of course, soBGP software. We need the infrastructure to generate certificates, very similar to what soBGP needs. We need, of course, certificates from other people that authorize us to advertise the route. These can be ISPs, registries, whoever you trust. And then you need to propagate these messages, these certificates, in BGP using the new security message. So right now, there's some drafts. Yes, they're expired. We plan to update them before the next IETF, next month in Vienna. We're working on the specific format for all the certificate, which are going to be XO9 type certificates of the specific mechanisms for PKI, etc. All that is in progress. And we're working on some of the code for iOS. One of the goals here, because of the offload processing and the fact that we don't need to necessarily store everything in the router, is to be able to run this on existing hardware. Note that I put some asterisks there, because of course that's a big if, but that's one of the goals that we have. If you want, ran out of time, if you want any more information, there is a website, there is a mailing list that anyone and everyone is welcome to participate in, and there's a lot of discussions not only on soBGP, but on SBGP as well, and other security stuff in the ArcSec working group in ITF. That's it.
Okay, we're running a little, low on time, so let me just throw one summary up, and then let's do the questions. Then I think people are concerned about lunch. Needless to say, there are things that I think about both protocols suck. Those who know me wouldn't be surprised by this.
Tell us what you really think, Randy.
But I do think we have the problem, and I want to steal from both of them. I won't really go into what I think sucks about each of them, but let me instead suggest what I might like to steal from each of them, and this is my personal view. Okay? The big costs in all this are going to be my deployment, my operational costs, not what Aaron's going to have to do to sign something or the cost of a little hardware in the router. Okay? Full deployment is going to take years. What I don't want to do is get caught out. Okay? It's going to be very hard to explain to my management 3 years from now when we have serious internet outages due to BGP problems, or next month when we have the next 7007 or whatever, why I'm not doing anything. Why I didn't already do something about this, and I'm not prepared to do something. Okay? The deployment we can do now is the beginning of the certificate creation and distribution. And that it comes in two parts. It's the address allocation certificates. In other words, the registry gives it to an ISP, gives it to, those are signed certificates. And there's the peer certificates. Hey, I trust Dave, Dave trusts Andrew, etc. I believe those are two different trust models. Both can use the same flavor of certificate. It's how the attestation chain of the certificates are done. I believe the peers are really more like PGP, and the address allocation is a hierarchy. And I believe the hardware support, we can ask for our vendors to start throwing those chips in now. I believe we should start trying to sign the origins now. In other words, hey, 1239 is authorized to announce route prefix X. I believe we can use the registry-based, in other words, IANA to RIPE and ARIN and APNIC and LATNIC to the ISPs, certifying that those addresses are in fact allocated, those prefixes are allocated now. Okay. I believe we can start building trust relationships with our peers. I am willing to pay for the hardware now. It's going to cost me $500 a router for routers that I'm paying $500,000 for. I can afford that 0.1% increment so management doesn't string me up 3 years from now when I have to turn it on. Okay? But what I most care about is that I have one planned protocol path and not something I'm going to do this year, and then I'm going to have to do something more 3 years from now when I realize the threat is bigger. Somebody else have their prejudices?
Steve Wilcox again. Okay, I kind of agree with what you're saying. What can we do now? As it currently stands, there's registries that you can register routes in, people aren't doing it. As it currently stands, everybody could register their routes and everyone could do prefix filtering on their customers and peers, and they could validate that every route that you receive is stored somewhere, even without the PKI and all that kind of stuff. We don't have anything like that right now. Well, you know, you could push on that today without having to update the technology.
I can't validate large peers based on routing registry data. The routers won't handle it.
But the routers will handle this?
I believe they will be able to, yes. Actually, when you actually look at, for instance, SBGP, you will find the change in computation is merely the crypto load, especially when signing forward, and the chips are commodity junk now.
So 10 years ago, ANS did inter-provider route filtering, and the headache was that you got, you had to wait. There wasn't a route refresh, so mechanism, so you had to bounce a route and you had to wait on a registry to be updated. Today we have incremental access lists. We have route refresh. You have, the missing part to every one of these solutions is some central authority or RIR or someone to delegate and say, this network owns this prefix, and they're authoritative for it. If you have that and inter-provider route filtering, it fixes 99% of the problems that that would arise, and we could do that today without any new hardware.
I don't think the new hardware is the problem. I think it's the infrastructure, the people, and the deployment costs.
Yes, and that's going to be 2 orders of magnitude larger for soBGP or SBGP. I think it would be great if this were deployed, but my point is that we don't have MD5, we don't have inter-provider route filters, and those alone would fix a very, very large piece of this problem.
Yep, but it's not going to fix all of it.
Yeah, no, I agree, but 99% of the problem is better than nothing, so.
Jeff Schiller again. What this actually can do, with which all the other things cannot do, is this can be forced on us, and that's actually a good thing. Right now, I can't force an ISP to set passwords on their routers. I cannot force an ISP to use halfway decent and to do MD5 keying on BGP sessions. I can't control beyond my peers and myself. But on the other hand, I can choose to only accept signed routes. Now, obviously, you can't do that on day one, but after the technology's been available and the infrastructure's been available, some number of years have gone by, the major providers can say, effective date X, we will only accept signed routes. And that's something you can do with this, you can't do with any of the other technologies that are out there. It won't be fun.
So to that, actually, I don't know how many service providers or how many folks in here have worked for a service provider that said stop reachability of those destinations, but I don't think that a flag day like that's actually even remotely realistic, because people there's revenue and real income associated with that, and that's what keeps those companies running. So that's not feasible.
And there's cost and real outflow for dealing with security breaches and support when things break. But yeah, that's going to be a tough call. We're years away from even being in a position to decide if we want to make that call. What's likely to happen sooner is some group of customers will only deal with a collection of ISPs that have adequate routing security, because they want to make sure that the places they want to get to are the right places. And I don't know if we're going to need the flag day, but I can say, yes, this is a route I can trust because of the following attributes that I can see on my BGP speaking router at my ends on my customer premises.
This is your router without security.
Hey, I see your tail circuit, Jeff.
Any pre-launch announcements, Ms. Harris?